Alright, so for 7-5, we are solving trig equations. Let's do a little bit of review. Okay? So, if you've got your calculator, I'm going to have you use it. If not, don't run and get it. We're not going to use our calculators on the rest of this, but I want to sort of review a little bit to show you have already solved some trig equations, but we just used our calculator for everything, and they were pretty easy trig equations. Okay? So, if I have a question like number 1, that is a trig equation. We are solving equations here, meaning we want to get the x by itself. It's different than the verifying identities. We want to get the x by itself. So, if I have tangent x equals 4 over 7, how do I solve that equation for x? How do I get rid of tangent? Inverse tangent, right? I would take inverse tangent of both sides, so x would equal inverse tangent of 4/7. And what that means whenever we haven't really thought about inverse tangent very much because we just type it into our calculator, but it means where does tangent equal 4/7? That's not on the unit circle, right? So we have to use our calculator for that. So somebody who has a calculator handy, do tangent inverse of 4 over 7 and tell us what we get there. What? What? 519. That's probably in radians. It does not matter. We just need to know which one it is so we can label it. Yes, radians. Does somebody have it in degrees? What have you got, Shane? Okay, so either one of those would be the answer. Okay, so we've done that before, right? We have to use our calculator to help us there. Now, number 2, I'm not so sure we've done one exactly like number 2, but I bet we can figure out how to do it. Still, we're using our calculator for this. So, if I have 4 cosine x minus 1 equals 0, I want to get the x by itself. So what do you think I should do first? I'm going to add the 1 first, then divide by 4. So I get 4 cosine x equals 1, and then I divide by 4. Just like you were solving a regular equation for x, right? So cosine x equals 1/4. And then I have to solve that for x. And how do I get rid of cosine? Inverse cosine. So I do cosine inverse of both sides. So x would equal cosine inverse of 1/4. So that is saying, where does cosine equal 1/4? That's not on the unit circle either, so we have to ask our calculator by typing in cosine inverse of 1/4. What do you guys get whenever you do cosine inverse of 1/4? 75.5 degrees, or if we did radians, 1.318 radians. And it doesn't really matter which one you use there. We're not going to be using our calculator, so it won't really be an issue for that with which mode you're in. This is just sort of to introduce us to recognize that we do know how to do these a little bit already. Okay, questions? Okay, so the next thing we've got to talk about are principal values. I'm going to let you guys copy that down first, and then I'll talk about what it means. This is pretty much all you've got to copy as in just the examples after this. Values. They repeat over and over and over and over again. And we could keep going around that unit circle thousands of times. So those values are infinite. There are infinite solutions to trig equations. So we usually don't need infinite solutions. We usually only need one solution, sometimes more than one. But we definitely don't need to know that the answer could be 100 or 460 or add 360 again and just keep doing that forever. So in order to narrow this down, sometimes we will solve for what are called principal values. Principal values are what your calculator gives you if you do inverse tangent, inverse sine, inverse cosine. Because the calculator, if you do inverse tangent, like we just did, inverse tangent of 4/7, it only gave us one answer. So it gave us one place where tangent is 4/7. But if we keep going around that unit circle, there's multiple places where inverse tangent equals 4/7. So, for sine and tangent, we narrow our search just to negative 90 up to positive 90. It's that first and fourth quadrant. Although we use these values, we use the negative values rather than using 270 to 360. So, first and fourth quadrant. And if you look at sine, sine's your y-coordinate. You got a positive and a negative. Tangent would be positive here, negative here. But we can't use the same principal values for cosine. Because notice, cosine is positive in both the first and the fourth quadrant, right? So if we use the same principal values for cosine, we would not ever be able to use it to find a negative value, which we sometimes have. So for cosine, we go from 0 to 180. This just tells you where to search for your answers. It's not really part of how to solve the problem. It just tells you what part of the unit circle to look at whenever you're solving these. Students sometimes will say, oh, I have so much trouble solving those principal value problems. Principal value doesn't really change how to do the problem at all. It's just where you look for your answers. Okay? So let's look at this in an example. So let's say that we have square root of 2 cosine x minus 1 equals 0. And we're going to solve that for principal values of x. And it did not specifically tell us whether we have to use degrees or radians, so you can use either. Just make sure that if you use degrees that you put a degree symbol for it. Radians are pretty self-explanatory if they have a pi in their answer. And also, we'll be using our unit circle a lot for this, so I'm going to try to do it all from my head. But if you are still having a little trouble with that, you might want to get out that unit circle. And I will give you a blank unit circle. We're going to have a quiz on solving these on Thursday, and then we'll also have a test next Monday. I'll give you a blank unit circle for both of those so that you can use that. Alright, so number 1 here. I've got this equation. I need to solve it for x. Okay, this is not verifying. I can move things from one side to the other. So I've got square root of 2 cosine x minus 1 equals 0. Okay, so I need to get that x by itself. I've got to add the 1 first. So I get square root of 2 cosine x equals 1. Then I need to get rid of that square root of 2. It is multiplied by that cosine, so I'm going to divide off the square root of 2. So I've got cosine x equals 1 over square root of 2. We're probably going to need to rationalize it because if I was using my calculator, it wouldn't matter. I'd just do cosine inverse, right? And it wouldn't matter. But you're not going to have your calculator for these problems. So that means it's got to be unit circle values. And 1 over square root of 2 is not on the unit circle anywhere. So let's rationalize that. Square root of 2, multiply it top and bottom. So we get cosine of x equals the square root of 2 over 2. So now what we would do is we do cosine inverse. But what cosine inverse does. It says, where does cosine x equal the square root of 2 over 2? Now, we are on, it said principal values. So, for cosine, our principal values are the first and second quadrant. So, where does cosine equal square root of 2 over 2? Okay, pi over 4, or 45 degrees. That is square root of 2 over 2, and square root of 2 over 2. Over here, at 3 pi over 4, does cosine equal square root of 2 over 2? Negative, so that's not an answer, right? Now, I'm only searching in this part of the graph here, so my answer right here is going to be x equals pi over 4, or you can say x equals 45 degrees. I do not care, unless I specifically say find principal values of x in degrees. Unless I say that, I don't care which one you give me. Just make sure that, if you have degrees, you put the degree symbol with it. Now, there was another spot where this equals square root of 2 over 2. But that's not a principal value, so I'm not looking there. Okay, so I wouldn't use that as an answer. All right, questions? You can always check these by plugging in your answer. So if we're going to check, so 2 check, I would have square root of 2 cosine of 45 degrees minus 1, and that should equal 0. So the square root of 2 times the cosine of 45 degrees is square root of 2 over 2. I'd multiply those together. I'd get square root of 4 over 2, which is really just 2 over 2, which is 1 minus 1, which gives me 0. So I know that I got it right. So you can plug these answers back in just like you would with any equation. It's just a little harder to do because you've got those trig values. Okay, question. All right, let's try our next one here. Okay, so we've got sine x cotangent x equals square root of 3 over 2. This one's a little different than the last problem because I don't have things where I've got 2 x's. I can't just move things to the other side and solve like I did. But if I do this, sine x times cotangent, what is that if I change it to sines and cosines? Cosine x over sine x equals square root of 3 over 2. Why is that helpful? Sine can cancel on top and bottom. Alright, so now I've just got cosine of x equals square root of 3 over 2. So these are different than verifying, but because you're actually solving for x, you're moving things from one side to the other. But we'll use some of those same strategies on some of the problems there. So this is a strategy that we used when we were verifying. And so now I'm doing cosine inverse here. I'm thinking, where is cosine x equal to square root of 3 over 2? And again, we're cosine, so we're not looking in that second or third or fourth quadrant. We're only looking from 0 to 180. And let's see, square root of 3 over 2, that is going to be right here, right? Square root of 3 over 2, 1/2, that's your 30 degrees. So x equals 30 degrees. In the second quadrant here, I'm going to have negative square root of 3 over 2, so that would not be an answer. So just the 30 degrees. Or, what else could I say? 5 or 6. Okay, questions? All right. Let's look at this next one. This is something that we use a lot in calculus when we've got trig equations that we're using for like optimization problems. So it is used a lot in some upper level maths. I can't guarantee that I'm necessarily going to use it, but we will not see the application here. We do some in calculus. Okay, so this problem we've got 2 cosine 2x minus 1 equals 0. And this time it did not ask us to find the principal values. It asked us to find the answers between 0 and 360. So this time we're looking at the whole unit circle, which means we're probably going to get more than one answer. Not necessarily, but probably going to get more than one answer. In fact, sometimes we get 3 or 4 or 5 answers. So now, whenever you see that cosine of 2x, my initial reaction is that I want to replace it with cosine squared minus sine squared, because that is what we've been doing in the last problems, in the last section. But in this case, it's actually better not to replace that. Okay? So what I would do is solve this like you would solve a normal equation. So I would add 1. So I would get 2 cosine 2x equals 1. And I would divide by 2. So cosine of 2x equals 1/2. Now, if you're trying to solve that for the x, the next thing you would need to get rid of is the cosine, right? You would do cosine inverse. So we're going to ask ourselves, where does cosine equal 1/2? So if we're thinking of the whole unit circle, okay? So right here we've got 1/2 root 3 over 2. That is our 60 degrees. Where else would be, no, that's wrong. Alright, well, let me do that. Be right. Here we'd have 1/2 negative square root of 3 over 2, and let's see, that would be 300. Now, here's the catch. We don't just have cosine x equals 1/2. We've got cosine of 2x equals 1/2. Alright? So, I'm not going to say that x equals 60. I'm going to say 2x equals 60. Okay? divide by 2, x equals 30 degrees. Which, if we think of it, makes sense because we want to take cosine of 60. If we plug in 30, when there's that 2 there, it'll be 2 times 30, which will give us 60. All right. But 300 would also work, correct? So 2x could also equal 300. We could divide by 2. X equals 150. Okay? Now, I'm going to really complicate things a little bit here. My answers so far are 30 and 150. I'm supposed to go all the way to 360, right? It sort of seems like 150 is just like right over here. It sort of seems like I should have something in these other quadrants, right? So, 60 degrees plus 360 degrees is going to give me what, 420? Alright, so 420 is another place where cosine of 2x equals 1/2. So if I've got 2x equals 420, and I divide by 2, x equals 210. Is that still between 0 and 360? It is. So that's also an answer. Even though 420 is not in the right range, when you divide by 2, it is. Okay? Let's try the same thing with 300. 300 plus 360 is going to give us 660. So 2x equals 660. Divide by 2. X equals 330. And that is still between 0 and 360, so it's also an answer. Now, I could keep going. I could take 420. And I could add 360. Let's see, that's going to give me 780. I think, yeah. If I take half of 780, is that between 0 and 360? It's going to be 390. So that's too big, right? So we would stop here because 390 is going to be too big. Okay, questions? All right. This is just the first half of the notes. So for homework tonight, we're going to have these problems. We've got a lot of other examples that we're going to do tomorrow. But for homework, we'll have these. Go ahead and get started. You got about 10 minutes. You can try a few of these problems.